Hello folks, we are taking up the miscellaneous exercise of chapter 5 and now we are taking up the second part of the video. The question 4 states that x minus yi root is given by root of a minus ib by c minus id. Having taken this fact, they ask us to show that x squared plus y squared, if there is a squared overall, yes, there is an overall square also, square is equal to a squared plus b squared by c squared plus d squared. Using this, we have to show this. So right away we can get into, but before we actually start, there's one result that I would like to state, that in complex numbers, we have a result. We know that. Suppose if you have a complex number and its conjugate, then we have a power of it. Then you can always exchange the power and the conjugate. That is, you can take the z raised to n and then take its conjugate. That way it's okay. So we are going to do that over here. Z we know is a complex number and every complex number is of the form x plus iy. Suppose say it has a power, you take the conjugate and then take the power, is as good as taking the complex number, considering the power, getting it simplified, then taking its conjugate. That also will do. Why we are using this? Because here we have got a power raised to half radical sign, right? So let's consider this. Here we are given x minus iy to be maybe now root always numerator denominator separately, if you write also no problem. So we are writing it separately. Now we plan to take conjugate on both sides. Okay, let's take conjugates on both sides. Taking conjugates. On both sides. So what will happen? You will have to take the conjugate of this, conjugate of this. So it's like x minus iy's conjugate and root of a minus ib. You will take the conjugate of this, and of course conjugate also, overall conjugate, it's okay if you take the numerator denominator separately, like that's a property, right? So conjugate of this number, we have learnt that in a complex number, when we consider the conjugate, we just change the sign of the imaginary term. So because it is x minus iy, it will become x plus iy. And here, now we have learnt this very property that if you have a power, then you can always take the conjugate and then consider the power. So actually this radical sign means it's raised to half. So there's no harm if you take the conjugate. See here, conjugate was outside, root was first. It's okay, let the conjugate come inside, let the root go out. That is also okay. That is what this property says. So a minus ib, take the conjugate, and c minus id, take the conjugate. They can replace in complex numbers, it's okay. So this will come to root of a plus ib, and this will come to root of c plus id, because we have learned conjugate means changing the sign of the imaginary term. What is the idea behind all this is that we'll call this as equation 1. Let's call this as equation 2, and let's plan to multiply them. Okay, let's borrow some place from here, and this we'll see you later. First let's do this. 1 into 2, we are multiplying. How do we multiply two equations? Multiply left hand side, multiply right hand side. So let's multiply x minus iy times x plus iy, and here root of a minus ib by root of c minus id, and here root of a plus ib and root of c plus id. So this we have learned long ago itself, that whenever these two conjugates gets multiplied, it comes to x squared plus y squared. Actually it will come to x squared minus I squared plus I squared y squared. Because of that minus I squared y squared, it will become x squared plus y squared. Then here root a into root b can be written as root ab. So you can have a common root and you can have it multiplied. This is the property of roots. So we have it like this. Here also c minus id and c plus id. Now same thing, conjugates are getting multiplied, so it becomes a squared plus b squared. Conjugates are getting multiplied, it becomes c squared plus d squared, or it can be written as a squared plus b squared by c squared plus d squared. Here it is x squared plus y squared. So in order to remove the root, let's square both the sides. So you'll get, that's That's all. That's how we prove it, right? So this particular result is proved in this way. That is our problem number 4. Now problem number 5, first part. Let's go to this, then maybe later we'll drop it and whatever. So this is our question number 5, subpart number 1. See, the question number 5 says that you have to express it in polar form. If you have to express it in polar form, then you have to have modulus and argument. And if you have to get the modulus and argument, you have to get x and y. If you have to get x and y, this has to be in standard form. It is not in standard form. So first, let's convert it into standard form. Then we will get the polar form and all that. So lots of work is there. Let's work with this. Consider 1 plus 7i by 2 minus i, the whole square. Let's see what this comes to. A minus b the whole squared is a squared plus b squared minus 2ab. So 2 squared plus I squared minus 4i, or rather it comes to, this is minus 1, we all know I squared is minus 1, so 2 minus 1, 1. So 2 squared, sorry, this is 2 squared, so 4. So 4 minus 1, 3. 3 minus 4i. I hope everything is correct. 4 minus, yeah. So now this, just one problem back we saw, if such a thing comes, let's multiply conjugate both in the numerator and denominator. So 1 plus 7i, let's get it multiplied by the conjugate so that our work becomes easier. Now this we know is always x squared plus y squared, so it will come to 3 squared plus 4 squared. Now here we'll do this opening up business. 3 plus 4i and 21i plus 28i squared. I squared is minus 1, we all know. And 3, 4, earlier sometimes I have told you about triplets, that 3, 4 and 5 is a triplet. If you know that 3, 4 and 5 is a triplet, 3 squared and 4 squared sum you need not write, you need not find out, you know it's 5 squared, which is 25. Or if that all that is not known to you, we'll find it out. 3 squared 9, 4 squared 16. Okay, now how about this? This is minus 28, so it's minus 25. Now this is 25i and here it's 25. So what comes? Minus 1 plus i. On solving, just check if it's minus 1 plus i. Yeah, I'm checking at every step so that we don't go far away then realize that there's a mistake. Yeah, this is fine, minus 1 plus i. What is the advantage? You have got it reduced in x plus iy form. We have to find out the polar form. So here x equal to minus 1 and y equal to 1. This is what we have got. That helps us to get the modulus r is equal to root of x squared plus y squared, which is minus 1 squared plus 1 squared comes to root 2. So you've got r. Now also you know that cos theta is x by r and sin theta is y by r, which means cos theta is minus 1 by root 2 and sin theta is 1 by root 2. So we have to find out the argument, and argument we have to do it in 2 phases. First phase is to decide what is the standard form, pi plus, pi minus, 2 pi plus, 2 pi minus, that way. That first we have to decide, and then you have to decide the angle. So first let's decide which quadrant this is lying. Cos is negative, sin is positive. Where should it lie? Second quadrant. Second quadrant is of the form pi minus theta. And what is this theta? That we'll find out from this magnitude. Sin 1 by root 2, cos 1 by root 2, which is that angle? Pi by 4, 45. So it is going to be pi minus pi by 4. How much is that going to be when we equalize? 4 pi minus pi, 3 pi by 4. So that's almost done. We have got the r and we've got the argument. So that helps us to get the value of this particular thing in polar form. So let's write. Therefore, in polar form, what comes? We have r times cos of the argument plus I times sin of the argument. So r times means it is root 2 times cos of the argument 3 pi by 4. I times sin of the argument 3 pi by 4. So that is about our problem number 5 subpart 1. 5 subpart 2, quickly we'll go. 1 plus 3 pi by 1 minus 2i. Now see, we will 1 plus 3i by 1 minus 2i. Now this is the same problem that's coming up here. We don't have it in standard form. So to get it in standard form, and for that what we do is we multiply with the conjugate both in the numerator and denominator. So we know it very quickly over here that this is going to be 1 squared plus 2 squared, x squared plus y squared, and this is all this opening up business. 1 plus 2i, 3i, and 3 2s are 6i squared, which is minus 6, and you have this 1 minus 6, so that's minus 5, and this is plus 5, and this is 1 plus 4, that's also 5. That also comes to minus 1 plus I. When you can take the 5 out and cancel the 5, you will get minus 1 plus I. What is the miracle behind that? That here also you have got the number minus 1 plus I. So the same procedure will follow, and by the same working as above, by same working as above, the polar form is the required polar form is same thing, root 2 times cos 3 pi by 4 plus I sin 3 pi by 4. That's about this question number 5, sub part 1 and 2. With the next question, we are meeting in the next video. Thank you.